Next, I'll work problem 3 from chapter 2, calculating the H plus concentration and the pKa from the pH of a solution of a weak acid. We're given that the pH of a 0.02 molar solution of the acid was measured at 4.6. So we're given the pH and the concentration. So what is the H plus concentration in this solution? So you might make an assumption that the H plus concentration is equal to that 0.02, right? Because you might say, well, that's my amount of acid. But remember, this is a weak acid equilibrium problem. So we've got concentration of the acid. I'm sorry, let me rewrite that. Concentration of the acid is equal to 0.02 molar, and the pH is equal to 4.6. Okay, so what are we asked to calculate? We're asked to calculate the H plus concentration and the pKa. And you might say, like I said, that the H plus, well, it must be 0.02 molar. No, remember, this is a weak acid equilibrium problem. We're not told what that acid is, but we know that the HA is equal to H plus plus A minus. Okay, it doesn't completely dissociate. This is a reversible reaction. So the concentration is going to be dependent on our pKa, and we don't know the pKa, so, or it's going to be dependent on the Ka, you might say, which is directly related to the pKa, and we don't know the pKa, so we don't know how far this is going to dissociate. So we need to calculate that hydrogen ion concentration, but in order to do that, we're going to have to use the pH. Okay, so we learned in the last video that we can calculate the hydrogen ion concentration with this equation. H plus is equal to 10 to the negative pH, and we derived that equation in the last video. So that's going to be equal to 10 to the negative 4.6, okay? And that's going to be equal to 2.5 times 10 to the negative 5th molar, which, if you want to convert that to micromolar, that's 25 micromolar. Okay, so 2.5 times 10 to the negative 5th molar is the H plus concentration at equilibrium, which is, like I said, determined by the pKa. Now, in order to find the pKa, because we don't know that, we're going to have to solve an acid-base equilibrium problem and then use this equation. Ka is equal to H plus times A minus over HA. Alright, remember that, but how are we going to find? We've got our H plus concentration, alright, but we need to find the A minus, okay? So we need to find all of these things. We need to find the HA at equilibrium also. So how are we going to do that? We can make an ice table. This is an equilibrium problem. So let's say HA is equal to H plus A minus, okay? I'm sorry. I need to use reversible reaction arrows. And let's make an ice table. Okay, so we're going to find our initial change and equilibrium. So initially, we know that our HA was 0.02 molar. Okay, and we had 0 of this and 0 of this. But as the equilibrium, as this acid begins to equilibrate, once you put it in water and reach that equilibrium concentration, we're going to lose X amount of HA that's going to dissociate into H plus and A minus. So this is going to gain X and this is going to gain X. So at equilibrium, we're going to have 0.02 minus X and X and X, right? Okay, so we can set up our Ka expression. Ka is equal to this H plus times A minus over HA. So remember, that's H plus is X, A minus is X, and then HA is going to be 0.02 minus X. So we've got X, X, and 0.02 minus X. So we can say that's X squared over 0.02 minus X. Okay, so we can plug some numbers in. The H plus concentration we found to be 2.5 times 10 to the minus fifth. Okay, so if that's 2.5 times 10 to the minus fifth, then if the H plus is 2.5 times 10 to the minus fifth, then the A minus must also be that amount. So we can say that is 2.5 times 10 to the minus fifth squared. Okay, maybe I should write this in. So Ka is equal, let's go back a little bit, to X times X. So we get an X from here, and we get an X from here, okay, over 0.02 minus X. Okay, so what is this H plus? We calculated this H plus 2.5 times 10 to the minus fifth. So we can plug that in, okay? But if X for H plus is 2.5 times 10 to the minus fifth, then the A minus is also X, so it must also be 2.5 times 10 to the minus fifth, okay? So that's going to be 2.5 times 10 to the minus fifth squared over 0.02 minus X. But we're going to make the assumption that we can eliminate this X, okay, because it's going to be a really small number, okay, usually. Now, I think that your book goes through and does the quadratic equation on this, but the answer is within 100th of the answer that they get, and therefore I'm just going to go ahead and use the approximation method by eliminating that X. Okay, and so that gives us 6.25 times 10 to the minus 10th over 0.02, which is equal to 3.12 times 10 to the minus 8. I'm sorry, 3.125 times 10 to the minus 8. So that's our Ka. In order to calculate pKa, we can say pKa is equal to negative log of the Ka, which is equal to negative log of this right here, 3.125 times 10 to the minus 8, and that's equal to 7.5. Okay? So that's how we solve this problem to find the H plus concentration and the Ka, given only HA and the pH. You know, I can't get my... There it goes. All right, thank you.